Cool, thanks. Hi everyone. This is Xiang. So today we are going to talk about data democracy. And here's just a little bit of my background. So I've been working in the streaming data area for about close to 10 years. And I'm a founding member and the PMC of Apache Pinot project, which is a real-time distributed OLAP, originally built from LinkedIn. And after I've been working on this project for many years, and I, along with Kishore and many of our previous colleagues from LinkedIn and Uber, we basically founded Story, and we want to use our experience for running this kind of real-time analytical technology in the industry to help build the next generation of the analytics platform and build the next generation of analytics applications. So now when we're talking about the data democracy, what are we really talking about, right? So let's first take a look at the life cycle of your data. So who is the data generator? Data actually being generated by your users of your applications or your product. And the values of the data right now should be shared by everyone, no matter those people are internal to your organization, your company, or they should be also your external customers or users, right? So now our current technology has done a great job of delivering those insights to the internal users, right? So you have data analysts or the data operators. So they actually know how to write a SQL, right? They also know how to build a dashboard, and they are also very good, very patient people. They can go to the micro kitchen to grab a coffee when the SQL is being running, or they go to lunch when I just submit a Spark job. But when it comes to your external users, when you try to bring those people the high quality insights in a timely fashion, this thing becomes much more challenging. So here I mentioned two things. So the first thing is a high quality insights. The second thing here is in a timely manner. So what do they mean? So let's first take a step back and think of the word in terms of many events that has been happening, right? So events is nothing but it can be or can be anything, right? It can be something like I'm currently giving a keynote, or I'm watching a YouTube video about how to do machine learning, or I'm just searching on Google for how I can write a for loop in my bash script. So it's obviously that all those events, as basically it's like the data, right? So they have its own associated values. It will drive how I can understand the current scenario and how I can make a good decision out of that. So of course, right, those value is being diminishing when the time goes on. So for example, when I just, let's say, open a food delivery app, say it's Uber Eats, because I used to work at Uber. So for example, right, so I open this app and I just type and browse, click on some restaurant, I type it and say, okay, the estimated delivery time is 40 minutes. I say, okay, I'll just open the search bar and type a burger. So what are those events mean behind, right? So since I made all those actions, so I know that I'm really hungry and I want to eat something right away, right? So those information to me is important, to Uber is also important. So if Uber is being able to know these things right away, they can actually give me some more, probably better experience. And also those information will be less relevant, say if Uber knows these things an hour later, or maybe just 10 minutes later, because typically 10 minutes is enough time for me to already put an order, or I just go to pick up some snacks. So the second part here is about to do things in a timely fashion, right? So just think about the time I can bring those events to your table. So before the streaming era, you typically need to wait for an hour or even days, right? So it depends on how good or bad your data infrastructure is. You can have those data for analytics. And the streaming solutions like Pulsar actually changed the game, right? So it reduced the event's delivery time from hours to seconds, or even milliseconds. So that kicks off a new set of the innovations from the industry. So let's still think about the Uber Eats use case, right? So back to the time, I just type the burger in the search bar. And if at the same time, I can get some coupon from Uber by saying, hey, this is something for you. And let me just order like a burger, or maybe 2 burgers if it's like buy one, get one free. And though it's 2,000 calories, but that's okay. So we call this thing as improved user experience, right? So for a better user experience, what are you getting? You're actually getting a more user engagement, which means as a user, I may consider use Uber more often. I may considering at home I will cook less. I'll probably order more food. By doing that, I'm actually generating more data for Uber, and Uber will learn from my behavior and from all those events to provide me better user experience. And hence, this whole ball is actually rolling, right? With more data, you're actually getting more improved or better experience. With better experience, you're actually getting more user engagement. Then you are also getting more data. So this is a very good positive feedback loop. So think of like those streaming technologies that actually opens up a flash gap for like so many use cases, right? So projects like Pulsar, it allows every user activities to be actually stored and tracked and consumed by any number of your downstream applications. You can take actions immediately after that. So log aggregation is another good use case that you can actually try to collect all the distributed applications log, and you have a central place which you can view all your operational stuff, and then you can do like a log search, you can do debug at one place. So technologies like Flink or Samza, those kind of streaming processing framework, what they're doing is they actually bring up those batch technologies up to streaming world. If you think about that, in batch world, you write a SQL, you write Spark job. Now you are also writing SQL. You write streaming SQL, you write Flink jobs in terms of like doing all those stream data transformation. And meanwhile, you have different data sinks, which you can dump the data to. And also, you can dump the data back to Pulsar for like streaming data store, right? So those kind of things are really make your world running on a stream. And the last thing here comes up is the real-time analytics. So this real-time analytics is only possible with streaming solutions because you need the solutions like Pulsar to serve those data as soon as possible. Meanwhile, you also need those streaming processing framework to help you to manipulate your data streams as you need, right? So now we can just talk about how we can do real-time analytics right. So it's as simple as you make 3 things right. First, you need to ingest your data as soon as the event happens. This means that when I'm typing like burger in search bar, Uber need to kind of know this thing right away, right? The second thing here is this query on this data has to be as soon as the data is ingested. This means that probably some coupon services behind need to query that, okay, some guy, Xiang, just typed the burger. So it knows that, okay, send this guy a coupon, right? So they need to make this thing happen immediately. The third thing here is you need to do these things at scale. At scale means that you need to ensure for like hundreds of thousands of users, they need to get the same experience. You are able to figure out like who you should send a coupon, what kind of coupon you want to send, and do all those things at a scale. So sounds simple, but actually it's also hard, right? So fundamentally, we want to like solve this problem in a systematic way. That's why we have built the Apache Pinot project for this to solve this kind of problem. So as I just mentioned, so if you consider those three things in the data world, they are called data freshness, query latency, and concurrency. So from the ingestion side, Pinot is able to consume directly from any stream data sources like Pulsar. And meanwhile, you can also use like a batch way, like a traditional way to bootstrap your data. That's not a problem. In order to make your query faster, Pinot internally has like multiple indexes to boost your query. For example, you have like inverted index or sorted index. Those things can help you to prune your data faster. You will have something like a JSON index, which will help you to look up your unstructured data. And Pinot has like something called structure index, which is built on top of your data to do some metrics pre-aggregation. So your analytics, your aggregations will be faster as well. So all those things has been built to ensure you will get your query latency as low as possible. So in terms of that, from the storage side, you also need to do compression. You need to ensure, okay, you are able to keep a lot of data on disk or on cloud. And meanwhile, you want to make sure that how you organize that data is scalable, right? So you want to move some data around. You want to make sure that you will be able to handle like petabytes scale. So not worth to say that like query ability is another important thing. It means that for my query, I need to follow probably SQL standard. This is everyone knows SQL right, in data. And apart from that, because we also support, for example, text search. So there will be some enhanced kind of features for how you can query the data. And probably the last thing is no need to say, but this is like a very important feature for any distributed system that you have to support multi-tenancy, which means your system is reliable and you have a resource isolation. You can co-locate some resources. For some use cases, you can separate them. That's super important for any online system to ensure things are reliable. So building this kind of data infrastructure is challenging. As I mentioned, this project is built originally from LinkedIn. To build such project at a big company is simple because you get you get good talents, right? So their engineering is good. But meanwhile, this is also hard. If you consider this thing as hard because you have to prove your value inside the company. So think about here, I can just take one example of LinkedIn who viewed my profile use cases. So for these use cases, you can just open your like LinkedIn and you will say, okay, recently who has been viewed my profile, my resume. This is a pretty good feature that PM proposed that they feel this will increase the LinkedIn user engagement. And the original solution built in 2014 was on a key value store. So for key value store to support this kind of use cases, at that time, LinkedIn has like about 200 million users and the QPS is only like 1.5 thousand per second. And in terms of supporting this, everyone goes to the idea, okay, for every member, just store a blob into a key value store. And during runtime, query it, application side, do your data massage. That's pretty much it. And after 2 years, when we are gradually learning, we figure out first, it's actually a very, it's kind of some overhead from the application side if they want to grab the data blob and do some massages. It's actually better for them just write a SQL, a more descriptive language, which they can query the backend, so that it actually reduce how they can reduce the time for them and effort for them to build any product. The second thing here is for Pinot project, it actually be more efficient comparing to key value store because you have more index and the more pre-aggregation possibility in terms of like getting the analytical data back. So in 2016, thanks to like LinkedIn's hypergrowth, and in 2016 we do the migration from key value store to Pinot. So at that time, the traffic has already been 3 times, and we will actually be able to support the same use cases with 15 times fewer hardware footprint, which means only 75 nodes can support what key value store needs 1,000 nodes to support. So this is a pretty huge success for Pinot project at LinkedIn, because users are happy because they are getting more analytical features, because they can find out, okay, how many recruiters are looking at my profile. And also now our SRE team is happy because they have fewer machines to manage. And the dev team is happy because in terms of their developer workload, that's also reduced. So once we realized, okay, this is a successful project at LinkedIn, the thing here is we want to say if this thing can actually benefit for the industry. So we open sourced it in 2015, and we hope it can help the industry, and we work with many companies for this project adoption. And gradually there are like more companies try it out. Uber later on becomes a key stakeholder for Apache Pinot project as well. We also know that an open source project can only be successful once there's a company backup, because you need more strong connection with the community, and you also need some people to build the vision and lead the development for this kind of open source project. So hence we founded Startree in 2019, and this is for like developing the project and also better serving the other companies and use cases. And in 2021, Pinot graduated from Apache and become a top-level project. That's like the project journey, and I'm pretty proud that the community has been grown like 3 times over the pandemic period, and also there are more companies that are trying out Pinot as well. Here's just a snapshot of the companies' logos that are using Pinot in production. Okay, so let's back a little bit to tech. So this is like one typical diagram if you want to fit Pinot to your existing infrastructure or your platform. So we can start from the left side. So on the left side, basically you have your internal applications, which will write all the critical bins pipelines, and have your critical bins data writing to, let's say, some OLTP, like distributed MySQL. And meanwhile, all your applications, tracking events, activities will be put into like a Pulsar to be consumed for like other applications or stream processing framework, right? So this kind of thing, like OLTP or Pulsar data will also be later on ingested into your data warehouse or your data lake. And then your data analysts, your internal users will be able to query it after the data are there, right? So typically this would be like hours data latency, freshness delay there. And here, if you want to place Pinot, you just put it along with your data lake or warehouse layer, and you can make Pinot directly consume data from Pulsar. This is just a direct consumption. You can think of like every topic in Pulsar will be a table in Pinot. And meanwhile, if you want to have your OLTP table inside Pinot as well, you can use like CDC to like Debian to like capture all the change logs, dump them to Pulsar, and then those data will be consumed by Pinot. You will try to, you can basically reconstruct your OLTP table here in Pinot as well. So once Pinot is there, you can build your user-facing apps. Think of like who viewed my profile, those kind of use cases for your external users. And meanwhile, we are not close the gate, or we are not preventing internal people to access Pinot, right? So internally, you must have something like a query builder or dash builder. You may use superset to build some dashboard on warehouse. Here, you can also do the same thing. You can build a dashboard on Pinot as well. So yeah, although I have been like talked this multiple times before, but I want to emphasize that this thing, again, that we have a pretty close partnership with Pulsar community, and ingesting data from like Pulsar to Pinot is simple and reliable. So if you want, you can actually try to make your Pulsar topic callable today, as soon as today. So from the previous diagram, we've been talking about the in parallel consumption from your data. And one thing here is that you find out the Pinot can actually be fitting to the place that being queried from both external and internal use cases, which means you can actually have the same definition of your data, which being used by both internal and external users. Take the example of like Uber Eats, right? So think of like you have all the orders data into one table. For your internal, let's say, analyst, what you can build a tooling to help them to debug, let's say, why, let's say for 11 to 12, this time period, why is the Soma area, the food delivery ETA, estimated delivery time is this long. This kind of tooling can help your internal business ops to improve their, to basically debug anything. But meanwhile, you can also use this order data to feed your customers, right? You can show your customers, okay, so here is your month-to-month like spending, right? You can show this thing to a restaurant manager by saying, okay, this is your restaurant estimate average delivery food delivery time. So please try to optimize your kitchen supply or whatever. Again, next thing is like for some fintech company. So you can try to just dump your ledger book into Pinot. That's as simple as it is. And the ledger book is typically the gold mine of fintech. Any fintech companies, they will have like internal ops team looking, have many tooling, inspecting the ledger book, trying to figuring out if there's any issue with all those transactions. If anything happens, they need to, the ops people need to actually debug all those transactions to figuring out if this is because of application bugs or it's actually some potential, let's say, financial risks or fraud use cases. Meanwhile, this is for your internal people to use. Meanwhile, you can also build some merchant dashboard or analysis for the small business who are using your fintech platform, right? So think of like WePay, they have been building this dashboard for their merchant. This can actually provide more detailed transaction analytics on their use cases, on all those small business transactions. And meanwhile, they can provide some, hopefully, like constructive advice for those small businesses. So in terms of like scale, LinkedIn as a social network, he is like leading in all areas for like the data ingestion speed and the query support, right? So LinkedIn has tried to like do everything at a millisecond level for all the queries. And we can try to keep the QPS at about 200,000 queries per second level. And meanwhile, the streaming side is like giving you 1 million records every second, single second as well. So from the Stripe side, because it's dumping the entire ledger book from day 0 of Stripe. So the data is growing every day. And now there are more than 1 trillion events in a single table, in their ledger table. And that single table is more than petabytes. So that's kind of the scale we are talking about when we are saying, okay, this is a table size. And everything is also in real time. So Uber is a pretty unique, like a real world business, right? So because you need to ensure your service is always up, is reliable, and your experience is consistent. You don't want any accident. So from the analytics perspective, we are facing the challenging that because this is the real world and this is like a local business, so we actually need to solve the analytical for all the geospatial queries, which means that you may only care about your local area. So a lot of queries and analytics things need to happen with all the geospatial indexing. And of course, for real time, you need low latency. So I do believe that this kind of user-facing analytics is really the missing piece of the puzzle for democratizing data. And the Pinot can actually bridge those between those internal and external customers and analytics. So here I also want to like just show off some more examples from LinkedIn and Uber, just to try to inspire probably people or the users. So the first thing is about Hoover profile, although I just talked about that before. But when this product is actually being launched, it improves the user engagement a lot. Why? Because it shows you that how your activities will impact the page view, right? Think of like if I'm adding some new skills or I'm adding some of my past experience, it will result some recruiter to get aware of me, and I'm actually getting to know that, okay, by adding more content or experience into LinkedIn, I will be able to get more page views. Or maybe I can also get to know that after giving this keynote, probably some more people will go to my LinkedIn to view me, so I actually know, okay, here are some impact, right? So this kind of things are pretty significant, and once those more user engagement happens, and you can provide a better product for the users, because the user will figuring out, okay, this analytics is very insightful and very useful. Another very good example here is about LinkedIn publishing analytics platform. For this thing, it's majorly for the people who are writing articles at LinkedIn. So from that, we actually provide the analytics on top of like your page views, and you will figuring out whatever the actions you have been made. For example, you will see the decay when time goes by, and you can probably see there are some bounce when you try to reshare the post, or some big guy just repost your article, right? And meanwhile, we provide audience analysis, which means you are able to know that who are the audience, what industry are they coming from, what are their job titles, and you kind of know this kind of information. And it will help the writers to figuring out, okay, how I can optimize my content. I can provide a better quality of the articles for the readers, and they will try to iterate by themselves. Just by providing this kind of product, you're actually improving the user experience. And you remember that the ball rolling, right? So it will result in more user engagement as well. And think of this will actually close your product loop in terms of like, okay, those users, they are generating data, but meanwhile, you're providing those users how you can utilize those data. Uber, yeah. So on the left side, it's called the Restaurant Manager. This is our first user-facing analytics product at Uber. What we were doing there is like, we provide all those kind of insights for restaurant owners. So it's not only just like showing you how much money you earned. When time goes by, we also provide the ability for like figuring out your, let's say, food quality and your estimated delivery time, how those things, critical business metrics change over there. And in terms of that, it can help those restaurant owners to better manage their business. For example, during the rush hour, you probably don't want a lot of people to wait because their dish may get cold, right? So you can actually pause the business for a while. And so your kitchen will be not so busy, and your in-dining guests and also the to-go orders for those users, they'll be feeling much better. And meanwhile, during the non-rush hour, you can actually use this kind of thing, this kind of tooling to help you like manage your supply chain and also try to maximize the utilization of your kitchen, right? So on the right side, this is some product called the Orders Near You. This is a very interesting thing. It's basically showing up in your Uber Eats feed. What it does is it will show what your neighborhood is actually ordering from, what kind of the restaurant are they ordering. So this sounds a little bit strange, but actually later on, people find out that this kind of thing can improve the user engagement in terms of like trying out a new restaurant, right? So think of like there's a new restaurant popping up on the platform and nobody has been tried out. It's probably better if you see someone try that out from the app. And also you will see some promotions or some reviews later on. That is actually some good idea to like do those new restaurant promotion. And of course, think of like if your neighborhood is trying to order from the same restaurant in a similar time, you probably only need one guy to deliver the food for them. So it can also improve your delivery experience as well as like improve the operational efficiency. So there are many things can actually benefit from that. So what I want to see here is this kind of capability of like user-facing analytics are actually opens up more like new innovations from the product side as well, right? So your product manager can become like more creative than you think. Yeah. Okay. This is it for my talk today. And yeah, thanks for coming on site or watch it online. And have a great day.